Imagine just for a second that you could actually see light, not just beams or brightness, but the way it moves, twists, and dances at the tiniest imaginable scale. Picture being able to witness the very building blocks of reality in motion, as if you had superhuman eyes that could peer into the heart of the universe itself. Smaller than a virus, smaller than a molecule. Welcome to the age of atomic vision. We're talking about a world so minuscule it's almost impossible to comprehend. A realm where the rules of physics get weird, and the ordinary becomes extraordinary. Scientists have just blown open the doors of what we thought was possible. They've created a microscope that can see light with 1 nanometer precision. That's not just a small step forward, it's a quantum leap in our ability to observe the universe. That's a billionth of a meter. To put that in perspective, if a nanometer was the width of a marble, a meter would be the size of the Earth. It's a scale so extreme it's almost like comparing a single grain of sand to an entire planet. This isn't just a technical milestone, it's a whole new way of seeing reality, and honestly, it could change everything from quantum computing to next-level medical imaging. The implications are staggering. We're talking about a tool that could revolutionize entire industries, spark new discoveries, and even reshape our understanding of life itself. So how does it work? Well, traditional microscopes have always had this annoying limitation. They can't see anything smaller than the wavelength of light itself. It's like trying to see grains of sand with a net that's way too big. No matter how hard you try, you just can't catch the details that are smaller than the holes in your net. But this new microscope, it's genius. It doesn't just look at light, it measures how light interacts with electrons at the atomic level. Instead of being limited by the size of light's wavelength, it uses the quantum properties of electrons to break through that barrier. Think of it like watching ripples in a pond, but the pond is made of atoms, and the ripples are made of light itself. Every tiny movement, every interaction is suddenly visible, like seeing the choreography of a dance that's been hidden from us until now. You see, by capturing these interactions, scientists can finally see light moving through matter, atom by atom. It's as if we've developed a camera that can freeze the action at the very edge of what's physically possible, revealing secrets that have been locked away since the dawn of time. It's like unlocking a secret code that's been hiding in plain sight all along. Suddenly, the invisible world is no longer out of reach. It's right there, waiting to be explored. But why does this matter? First, it's not just a cool science trick. This is a game changer. The ability to see and understand light at this scale could lead to breakthroughs we haven't even imagined yet. Imagine quantum computers that are smaller, faster, and more reliable because we can finally observe how light and matter interact at the smallest scales. We could design new types of processors, invent ultra-secure communication systems, and even unlock new forms of artificial intelligence. Or medical imaging so precise it could catch diseases long before symptoms show up. Early detection could save countless lives, and treatments could become more targeted and effective than ever before. We're talking about designing materials atom by atom, super efficient batteries, ultra-strong materials, or electronics that make today's tech look ancient. The possibilities are endless. Imagine solar panels that capture nearly all the sun's energy, or medical implants that are perfectly compatible with your body at the atomic level. And the scientific community? They're losing their minds over this. The excitement is contagious. Every new discovery opens up a dozen more questions, and the race to explore this new frontier is just beginning. Experts are calling it a new era in optical microscopy. It's a phrase that captures the sense of wonder and possibility that's sweeping through labs around the world. It's like we just got handed a pair of X-ray goggles for the atomic world. Suddenly the invisible becomes visible, and the mysteries of matter are laid bare before our eyes. Suddenly, things that used to be invisible, like how energy and information move inside materials, are crystal clear. We can watch the flow of electrons, the transfer of heat, and the movement of information in real time at a scale that was once pure science fiction. And here's my favorite part. For the first time, we can literally watch light as it dances through matter. It's a spectacle that's both beautiful and profound, revealing the hidden rhythms of the universe. It's like peeking behind the curtain of the universe and seeing the choreography of the cosmos itself. Every photon, every atom, every interaction is part of a grand performance that's been unfolding for billions of years. Seriously, I get goosebumps just thinking about it. This is the kind of discovery that inspires a whole new generation of scientists, dreamers, and explorers. So, what's next? With atomic vision, we're not just pushing scientific boundaries, we're redefining them. The future is wide open and the only limit is our imagination. If this kind of breakthrough fires you up as much as it does me, hit that subscribe button and stick around for more mind-bending science. There's a universe of discovery ahead, and together, we'll be at the forefront of it all. The invisible universe is waiting. And trust me, you won't want to miss what we discover next. The adventure is just beginning, and the secrets of the atomic world are finally within our reach.